going to be hearing from Branden Iles, one of the co-founders of Ampleforth. He's going to be speaking on intro to Ampleforth, Ampleforth's multi-chain vision, and how Ampleforth works with Chainsafe to execute on it. Greetings, Branden.
Hey, yeah, thanks for the intro. Can you all hear me and see me? Let's see. Hey, yeah, so happy to be here. Really excited. I think Chainsafe is doing some really cool stuff to enable like the whole multi-chain landscape in front of us. I'm going to talk a little bit about Ample. The first part, I'll talk about the project, what we're doing, where we're going. Then I'll talk about how Ample and we see it working across multiple chains simultaneously. And then specifically how we're working with Chainbridge to sort of help make that happen. I'll go into pretty deep architecture stuff too. So stick around if you're interested in the more technical side. But first, I'll start more high level, which is a little bit more economics related. So first, what is Ample? Ample is a base money digital currency with an elastic supply. So what that means is it's uncollateralized, similar to Bitcoin. It doesn't rely on collateral or the value of any outside asset. And it has an elastic supply that adjusts every day according to demand in the marketplace. So from a very high level, if the current price of Ample is above the price target, that means we need to increase supply. And when the price in the market of Ample is below the price target, it means we need to decrease supply in order to point the system back towards the equilibrium price target. So what this does is it gives you two qualities of money that we've never really seen together before in the same place. So one, it has it's non-dilutive, right? So the unique way in which we adjust supply is that everyone in the world has equal standing. So when new supply gets created, it goes towards everyone proportional to what they own. And when supply
here, but the screen that you're sharing is not your slide. That's what you intended.
Oh, okay.
Maybe just hit share screen again, and it will give you an option to choose a different window.
Okay.
Perfect.
Okay, great. Sorry. Here we go. Right. So we have so Ample has two qualities that you don't normally see together, or we've never seen together. So one, it's non-dilutive, meaning that if you own 1% in the network, you always own 1% unless you decide to buy or sell. This is sort of the soundness property that everyone likes so much about Bitcoin, and commodities and precious metals and that sort of thing. But it also has a long-run equilibrium price target, meaning that it unlocks a sort of unit of account. And this is especially useful for contract denomination and denomination of debt, right? So here's a very simple example of where Ample being used as base money could lead to a sort of safer sort of system of finance above it. So imagine Alice and Bob just enter into a bet. So Alice bets Bob that the Lakers will get into the 2021 NBA semifinals. If they do, then Alice will pay Bob 10 coins. Otherwise Bob will pay Alice 10 coins. So if Alice and Bob were to use something like Bitcoin, they're exposed to the volatility of this asset, right? So if I bet you 10 Bitcoin to be paid back a year from now, neither of us know how much that's going to be worth in terms of raw purchasing power. So whoever has to pay that might be on the hook for much more than they expect. That can lead to default. There's a high risk of default, and the more volatile this asset is, the higher that risk would be. Now, the neat thing about Ample is that when you denominate with the unit of account, no matter what happens to the overall Ample supply, you always know how much you're going to be on the hook for, for your obligation, right? So if you owe see 10 amples. Even if the overall supply of ample and market cap went way up or way down, you're still going to be paying back 10 amples, which is roughly 10 2019 US dollars. So the price target of ample is the 2019 US dollar to maintain a sort of constant purchasing power through time. So people often use the word stablecoin around our project, but we don't really view ourselves as a stablecoin. So today's stablecoins, they either there are two main types. There's the ones that rely on the U.S. dollar sitting in a bank account somewhere, or there's sort of collateralized stablecoins. So stablecoins like Tether, USDC, they rely on centralized banking relationships, and the idea, hopefully, of all the work that we're doing in the sort of decentralized sphere and blockchain world is to sort of remove the reliance on these private relationships, to remove the needed trust. Right? We kind of view the goal of centralized finance and blockchains as being able to create a sort of new monetary system that's beyond the reach of politics. And so we want to remove those layers of trust as much as possible. And the other types of stable coins that people tend to think about next are the sort of collateralized stable coins. And so debt-derived monies, can't rely completely on, free market incentives alone. And, if they rely on lenders of last resort, then they also, rely on periodic bailouts, which we've seen through history, over and over again. So I think there is a risk of us, recreating the history of finance and having everything play out exactly the way it has before, except maybe in a petri dish rather than a different sphere. And so Ampleforth is an attempt to do something different, a sort of new formulation of money that can give us a sort of safe, resilient financial infrastructure without having to rely on these weaknesses that we've seen before. So before I get into the multi-chain architecture, I can still talk about how it works on a single chain. So right now we're deployed on Ethereum. We started this project in early 2018. So we've been working on it for a good long time now. It first went live in the summer of 2019. And so we have, a year and a half's worth of market activity that we can look at. We're currently deployed onto Ethereum because that was sort of the most used and most established platform out there with a lot of developer activity. When we first started the project, we made the at the time somewhat controversial decision to not build our own blockchain. So instead of creating our own silo and asking people to come to us, we decided that we would instead go to where people are already storing value or making transactions or creating contracts. Right? So we decided to deploy on top of Ethereum. So these are the main components of the system. Ample is a token that implements the ERC20 template functions. So it's tradable just like any other ERC20. There are balances, there are transfer functions. But the ERC20 is directed by a supply policy. So supply policy is another contract also deployed on Ethereum. And what that does is that examines the data that comes in through our Oracle system and then calculates how to adjust the supply. So the supply adjustment happens once a day. It's called the rebase. So if you've heard of rebase tokens, it's been a kind of area of interest or curiosity recently. Ampleforth is a project that sort of introduced the concept of elastic tokens or rebase tokens to the world of decentralized finance. And so the monetary policy once a day has this rebase function that takes in data from two different oracles. It has a market oracle and then there's CPI oracle. So market oracle provides the 24-hour volume-weighted average price of Ample in the marketplace. And then the CPI oracle takes in a measure of consumer price index that allows us to target not the current day's US dollar, but the dollar at a particular point in time. So we're we target the 2019 US dollar, the day of the network live, so that we can have a steady level of target purchasing power without having to be exposed to the natural devaluation that happens from the tools available to existing central banks. So it's fairly simple. 3 main components: the oracles, the supply policy, and the token contract, the ERC20. The rebase function is a publicly callable function, so anyone can poke this as long as it's within the time window, and it can only occur, at most once a day. All right, so Ampleforth across chains. So a monetary asset is defined by 2 qualities. It's defined by the nature of its scarcity. It's defined by its use value. So those 2 things are what make, say, Bitcoin different from ETH, right? So the nature of scarcity of Bitcoin is it has, a supply ceiling of, that will never go beyond. And then it has no use value aside from being able to pay for transactions on the Bitcoin network. ETH, its scarcity is determined by its, emission from the miners, or staking rewards in the case of ETH2. And then the use value is that you can use ETH to pay for computation on the distributed computation platform. So for Ample, the nature of the scarcity is the supply policy in the rebase function curve. And then the use value is it's a pure monetary asset similar to Bitcoin, where there's no non-monetary use. And so there's no sort of outside source of bias in the value of an individual Ample. It's purely its monetary value. So when you think about Ample existing across multiple chains, as long as Ample is on chain A and Ample is on chain B respond to the same monetary policy, as long as you can freely transfer Amples back and forth, then they're all the same Ample, right? So when we think about Ample on multiple chains or multiple chain ecosystems, we're not doing parallel deployments on each chain individually in different silos. These are all the same Ample, controlled by the same monetary policy. So even going back to the single chain architecture, right? So you can imagine a ERC20 existing on lots of chains, but the monetary policy and the oracle only really need to exist in one place. So ideally, those would exist on the chain with the highest level of decentralization. It does a low volume of work, and so the cost of these operations is not that much of a concern. Instead, we care about security and decentralization. And the ERC20s can exist in lots of places. So on a remote chain, we might have a deployment of the ERC20 that gets rebase instructions over a bridge. But even on the same chain, we could conceivably have 2 different ERC20s. Like we could have the existing ERC20 Ample. We could also conceivably have a privacy version of Ample, right? That uses like zero knowledge proofs. So maybe you can use the privacy version of Ample on Ethereum to get privacy, but you have to pay higher gas costs to do that, right? So this is an example of 2 different contracts being controlled by the same monetary policy that's still all Ample. So that's the high level of how we think about Ample across multiple chains. I'll dive into the architecture and how it's all going to work and how we're going to work with Chainsafe here too. So this diagram is a generic bridge, right? So you have one chain on the left and then one chain on the right. There's a handler on one side. So say you called a function on that handler that would write to the logs. Relayers would pick up the events from those logs and then report it to the handler on the other target chain, right? So as long as enough relayers write the report and it's confirmed, then it calls this callback function that executes the function on the other side of the bridge. Should be pretty simple. Chainbridge has some existing handlers for like ERC20s, and then it also has some handlers for generic data passing or transaction function calls. So even though Ample implements the ERC20 functions, we decided to go with the generic handlers rather than the ERC20s. It should become clear when we get there. So really, there's two jobs that we wanted the bridge to handle. One is transfer amples, and then two is to marshal the rebase calls. So here's how a transfer works. So there's a lot going on here, but hopefully I can walk you through, and hopefully it's visible. So it starts here with the depositor, the little stick figure on the bottom left side of the screen. This person decides that he wants to send some ample from one chain to another chain, right? So he initiates a transfer, say 100 ample. So this 100 ample gets sent to, or this transfer method gets sent to the generic handler of ChainBridge. What this does is going to lock up 100 ample into essentially a vault. Say it's going from Ethereum to Polkadot, right? It locks up ample onto a vault on Ethereum. And then once that happens, it logs that deposit into the bridge logs. Now, when the relayers pick up these events, they report it to the other side of the bridge. It goes through the generic handler again, and it calls a mint. So on the target chain, we have what we call a sort of bridge secured version of ample, right? So the bridge receives this transfer event and it mints new ample on the other side. And so the mint ability is, as you can imagine, it's a very important call that not everyone should be able to call. This is only callable by the bridge. So this is why we call it the bridge secured version. So the trust model of the ample on the remote chain is purely whatever the trust model of the bridge is in this case. So it mints a new ample for the particular recipient. And so that should be pretty straightforward. However, there's one wrinkle. Because remember, we have two different jobs that are going at the same time. One is transferring of tokens, and then one is the rebases that impacts everyone's balances, globally. So you can imagine if you don't handle this correctly, you can get into some really scary race conditions. So imagine, there's a positive rebase, and someone is able to race the rebase function across the bridge. So say I have amples on Ethereum, I get a positive expansion. So like my 100 amples turns into 105 amples. And then I immediately transfer those amples over the bridge before the rebase gets there. And then once the rebase gets there on the remote chain, I get the rebase operation again, right? So this would let me double rebase my balance, right? Or on the opposite side, if there's a contraction, I can race in the other direction. So I can wait for contraction to happen on Ethereum, and I can immediately send from the remote chain back to Ethereum before the negative rebase applies to my balance on the remote chain. So that way I'm able to escape contractions. So that's something that we need to make sure to avoid, right? So this goes back to why we use the generic handler, because to solve this problem, we include one extra piece of data, which is the supply at which the transfer happens, right? So you can see this, the data here on step one is transfer 100 amples at 50 million. So that's the total supply. So if by the time it's interpreted on the other side of the bridge, if the total supply is now 55 million, that 100 ample will actually be 110 ample that will be received, just because that would have been 110 ample on the base chain as well. So this is how the rebase works. The rebase is a simple transaction or function call. It should be pretty straightforward if you just imagine it being a generic handled transaction, except there is one other job that we do in the Ample system, and that is we have this, I guess, fourth module in the system called an orchestrator that you can see within the box on the left here and also on the right. And what this does is whenever a rebase happens, it notifies downstream consumers of the rebase event. So this is useful for some platforms that are not able or not yet able to support Ample. They need to be notified to sort of update their accounting. So for example, Uniswap and Balancer pools of Ample, they need to be notified that rebase happens so they can update their accounting and remain up to date with the actual balances underneath. So the orchestrator is just a generic function relayer or transaction relayer. So it stores a list of transactions that just executes one by one when the rebase happens. And so on the remote chain too, we also have a similar component called essentially the orchestrator, in case it needs to update some platforms on the remote chain as well. So I guess that's the only other wrinkle around rebases, is just this sort of orchestrator call. Now, of course, the architecture on each side, we sort of abstract away as much as we can the particular details of bridges, because we want the bridge secured version of Ample to be able to sort of be perennial and sort of evolve with the space. And so as bridge technology evolves too, Ample can sort of roll with the innovations as it happens. Yeah, so that's all I had planned to talk about. Some of you have probably heard of what we're doing before, some of you not. So I'm really happy to talk about what we were doing, and then I'm glad I could get into the details of the chain here. Let's see, I think there's some time left. Can we do questions, or are there any questions in the chat or anything like that?
And yeah, we do have a few questions, but I just wanted to thank you for taking the time to speak with us today. And we're really excited about the potential synergy between Ample and Chainbridge. And when we started to design the generic message handler, this is exactly the type of use cases that we had kind of envisioned as like the dream scenario for Chainbridge. But we do have some question and answer.
Sure. Yeah, we're also super excited about the work that you're doing. I think the ecosystem has the potential of getting very complicated, but with the systems you're building, I think it becomes manageable. So it unlocks a lot of different sort of experimentations and building that I think is going to be really exciting to see.
I really appreciate that. So one of the audience members is looking for clarity. So they say, so is Ample only as volatile as the market condition for the day? If market conditions are stable, Ample is stable, and vice versa.
Yeah, so I guess it depends on how you define volatility and stability here. So there's kind of two dimensions for Ample. One is the supply, and then one is the price of the individual token. Essentially, the protocol attempts to shift volatility from unit price to supply. So the overall supply or market cap long term could vary wildly, while the price of the individual token could stay within a band around the price target, so roughly $1. And so the protocol has no direct impact on price. Price is purely determined by the marketplace. But the protocol can control is the supply, and then it relies on the marketplace to reinterpret this supply back into the price.
That definitely clarifies it. Thank you.
Cool, yeah.
So somebody else is also asking, what chains are you most interested in integrating next?
Yeah, so I think so. There's lots of really interesting projects out there right now, and it seems like all of them seem to be coming to market around the same time, and they offer sort of different trade-offs and different existing use cases or engagements. Given the nature of this work, like it's potentially the security model is very complicated. It's potentially very dangerous to do this kind of thing if you get it wrong. And so I think we're most interested in doing the least risky integrations first. So Ample is a sort of permissionless asset, so it doesn't have to be us that sort of does these deployments. But I think it's good for us to do the first few to set the pattern of how it's going to work. So I think I think it's just from a purely development perspective, anything that's, since we're already on Ethereum, anything that is as similar to Ethereum as possible is a great candidate for first deployment. So we recently announced this week that we have specific plans to deploy and work with the teams for Tron, Polkadot, and Near, and specifically the Collateralized chain within Polkadot.
Okay.
And so I think because of the similarities between Tron and Ethereum, I think that it's most likely going to happen first. And also I think they have perhaps the most number of users and highest level of engagement of a platform outside of Ethereum. So I think we're also kind of excited to bring Ample to the new audience there as well.
I think it's a very, very prudent approach.
But we do we don't want to deploy or integrate with the chain just to say that we did. Like, we do want to go into an ecosystem where Ample can be used, for its desired uses, which is, as a piece of collateral, as a base money, something that can unlock, borrowing and lending, safe contract denomination, and everything that you sort of see in DeFi today. So I think, those three have the potential of doing that. So Akala, for example, we're going to be supported as a first-class fee token. So you'll be able to pay for your transactions with Ample, and we'll also be supported on the DEXs there, and hopefully on their stablecoin system as well.
Okay, cool. So next question looks like it's a bit more technical. So is the time of the rebase execution deterministic? Can individuals know if the rebase will produce the price ahead of time and sell prior, so arbitrage opportunities might exist as a result of that?
Exactly. Yeah. So it happens within a 20-minute window. So between 2 a.m. and 2:20 a.m. UTC, the rebase has to happen within that window. If it misses that window, then it doesn't happen for that day. So what this does is it guarantees, complete transparency and full market knowledge to everyone involved, right? So everyone has sort of equal access to information. And the purpose of the rebase too is, obviously there are arbitrage opportunities, and we think that helps lead the system back to its sort of equilibrium state over time. And then, the purpose of we designed the rebase function not to immediately bring the price back to the target, right? Because what we wanted to do is we wanted to assume the least amount of information possible of the marketplace. We just wanted to set the conditions such that the sort of directions or the slope of the system always points back to equilibrium. And as long as everyone knows that, then eventually it will sort of reinforce that behavior.
Awesome. So the next question is surrounding Chainbridge. So how is the process of integrating Chainbridge?
It's been good so far. It's been good. I think it provides a very solid framework to work from. The Chainbridge team has been really responsive too. So when we had particular questions or, just like small technical changes here and there that were sort of required to support the use case, everything was very smooth. So I think Chainbridge provides, it's very easy in the beginning if you want to start with a very centralized, very predictable system. They can sort of gradually sort of move towards decentralization over time. And so we really like that property a lot. And so, Chainbridge has been, a sort of great project to work with so far.
Thank you. And so finally, what inspired Ample in the first place? Curious if it had anything to do with your previous project or experience.
So I think, the easy but honest answer is Bitcoin, right? So, both me and Evan were sort of exposed to Bitcoin in the early days of, crypto, when it's just called Bitcoin. I also co-wrote the first Bitcoin wallet that was released on the Android Play Store back in 2011. So I've been really interested in sort of the space of government independent monies for a long time. I think it's really fascinating, and just the idea that you can create something like a new precious metal or a new, independent money like this is kind of magical. And so once Ethereum launched, then it seemed like there was finally the abilities for us to solve what we thought were the biggest drawbacks of Bitcoin and also fixed supply currencies. And so that's when we really started thinking seriously about starting a project like Ampleforth. Originally it was called Fragments. If you've heard of Fragments, It was a much more complicated system, relying on interlocking markets of bonds and reserves and whatnot. But as we worked with it more and more, we decided that, hey, these things are actually very fragile, and so we wanted to create something that was as simple and sort of predictable as possible. And so that was sort of led us to Ample, implementing it.
Awesome. Well, thanks again for taking the time to speak with us today, Branden. We're really looking forward to kind of Ample coming into its own and working with you moving forward.
Yeah, well, thanks for inviting me. It was a lot of fun, and glad I could talk to all the Chainsafe folks.
Of course. Awesome.
Yeah.
Talk to you soon.
Bye.